Well, hey guys, for this investigation, you're going to need some borax laundry powder. You're going to need a cup and some water. And then finally, some glue. Elmer's glue should work. I have Elmer's wood glue. I've never used it before, but we'll see how that works. And probably an extra cup as well. Then you'll also need some kind of a stirring stick. It could be a plastic spoon, a wooden stir stick, or whatever it happens to be. There's no real recipe for this, so this gives you an opportunity to kind of play around with different proportions of the materials as you're putting them together. One thing that I would encourage you to do is, if you have a piece of paper or a notebook, write down some of the properties that you see with the borax before you put it in water and the glue itself. What does it look like? How does it respond? It's like the borax is granular. Just take a few minutes and write down some observations about each of these materials before you actually do the investigation. So then, when you've done that, the next thing you're going to do is make some borax solution. And again, there's really not a recipe for this. So I'm just going to put some borax in water, and then I'm going to mix this up. I've got a lot of borax in there, but that's okay. It's going to dissolve the borax in the water. Okay, there I go. Once that's pretty dissolved, then again, I can make some more observations of this. Is it clear? Are there still chunks of borax in there? Yeah, just write some observations about that. Okay, then I'm going to take another cup. I'm going to put some of that solution in here. That way I can save this for later. So I've got a little bit of borax solution at the bottom of that cup. And I'm just going to add some of the glue to it. Okay, there I got a blob of glue coming out. I'm going to put it in the borax. Get it in there, maybe. All right, there it's in there. Okay, now the next thing I'm going to do is mix it up in there. Okay, mix it around in the borax solution. And because I made an observation of the glue before, I know how sticky it was and how it would have stuck to my hands. But now that it's been in the borax solution for a little bit, I can pick it up and I can kind of mush it around a little bit, get it well saturated in the borax solution, kind of squish it around. But look, it has changed in its property. Whoa, okay, it feels different, it acts different, and there you go. Okay, now if I've got a little bubble of raw glue in there, I can pop that little bubble and put it back in the borax solution. Okay, this is what you're looking for at the end. Now take a look at the properties of this material. Okay, what happens if I use less borax solution? What happens if I use more? What happens if I use more glue? What happens if I use less glue? Okay, this is what we're looking for at the end. And again, make some observations of that, and then we'll come back and talk about what has actually happened, and we'll make some sense of this. Okay, so there's that part. Okay, now let's share your observations. What did the borax look like before you put it in the water? Just talk a little bit about that. You can share in your table groups, you can share out loud, however you want to carry on that conversation. What did it look like when you made the borax solution? When you dissolved the borax in the water? What happened when you put the glue in the borax solution? And then what was the property of the glue after it came out of the solution? And you have lots of other things you can say about that. Okay? So, you probably have all made paper chains like this before at Christmas time, holiday time. You know that you start off by making an individual chain, just one loop, and then you hook another one onto that. And in the case of this illustration, you alternated colors. It doesn't really matter. But you end up with a really, 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 really long chain. And if you're really bored, you just keep going forever. And that's kind of cool, all right? Well, that's what happened to the glue when we put it in the borax solution. The single loop is called a monomer. It's mono meaning one. And then when you put those together, you end up with many of those, or poly of those, and so we have what's called a polymer. This is a physical representation with the paper chain of a monomer and a polymer. Well, the same thing happened here, only it happened chemically. So again, we started off with a monomer. That's the one on the left-hand side. There's only one of those. And then in this case, this is styrene molecules at the top, and they start hooking together one after another, after another, after another, after another, and it creates a polystyrene or a polymer. And the same thing at the bottom. You can see we started off with the black grayish circle represents carbon, and the blue dots represent hydrogen. So you have a carbon-hydrogen monomer on the left-hand side, and then those all start getting hooked together, making a polymer. If you have a long string of polymers, that's going to have a particular property. But sometimes you can have polymers that have branches off the long string. Depending upon how they're arranged chemically, they're going to have different properties. So these are some typical properties of polymers. In general, the longer the chain, the stronger the polymer. And again, as I mentioned, you can have side groups. And those side groups, we have the word polar, meaning they're attracted by polar attraction, positives and negatives. And as you have those side groups, you have a stronger attraction between the polymer chains, and that makes the polymer even stronger. And you can also have branching and unbranching chains that pack together more closely than highly branched chains, and that gives the polymers a more crystal-like structure, and that makes it even stronger yet. And finally, you can have cross-links, where the polymer chains are linked together by a bond called a covalent bond, and that polymer is really, really hard, and it's really, really difficult to melt. So again, depending upon how chemically those monomers are arranged in polymers, you get varying strengths of the material of the polymer. So again, other properties of polymers is you can have some that have a low melting point. They're very, very flexible. You can have some that have a relatively low melting point. They're a bit more rigid. And you can have some that have a very, very high melting point, and they're very rigid. And an example of that would be Kevlar. You've probably heard of Kevlar. It's a material that they use on bulletproof vests and things like that. There's also some fire-resistant properties to Kevlar. Okay? DNA, the DNA that's inside of our bodies, is actually a polymer. It is made up of long, long strings of monomers, in this case they're proteins, and they're all put together and they're arranged in a way that they just have these chains and these links. If you've done any biology, you know that you can actually break the DNA and it can reform, and that's how genetic codes are transmitted within an organism. But a DNA molecule is a polymer. Other examples of polymers in real life naturally are rubber, wool, wood, silk, and paper. Those are all natural polymers. Then we can actually create synthetic polymers as well. So plastic, nylon, silicone, polystyrene, it's like a styrofoam cup, styrofoam, polystyrene, see the connection there? Polyethylene, those are like pads, like sleeping pads that go out when you're camping, things like that. So those are all examples of synthetic polymers. Also, you can see some here with plastics, toys, but fabrics can also be synthetic polymers. So polyester, again the word poly meaning many, links of chains of the material, is a very common synthetic fiber. And it is made chemically. Nylon is another polymer, and they can then be made into strands like threads, and then we can use those to make fabric. So that gets you to what you're talking about now with different types of fabrics, and hopefully that makes a little bit sense, and I'm curious what you're going to do next. So let me know what your next investigation is, but hopefully that makes some sense about polymers.